in your book, A Beautiful Question, you ask, does the world embody beautiful ideas? So the book is centered around this very interesting question. It's like Shakespeare. You can like dig in and read into all the different interpretations of this question. But at the high level, what to you is the connection between beauty of the world and physics of the world?
In a sense, we now have a lot of insight into what the laws are, the form they take that allow us to understand matter in great depth and control it, as we've discussed. And it's an extraordinary thing how mathematically ideal those equations turn out to be. In the early days of Greek philosophy, uh, Plato had this model of atoms built out of the five perfectly symmetrical Platonic solids. So there was somehow the idea that mathematical symmetry should govern the world. And we've out-Platoed Plato by far in modern physics because we have symmetries that are much more extensive, much more powerful, that turn out to be the ingredients out of which we construct our theory of the world. And it works. And so that's certainly beautiful. So the idea of symmetry, which is a driving inspiration in much of human art, especially decorative art, like the Alhambra or in wallpaper designs or things you see around you everywhere, also turns out to be the dominant theme in modern fundamental physics, symmetry and its manifestations. Because the laws turn out to have these tremendous amounts of symmetry. You can change the symbols and move them around in different ways, and they still have the same consequences. So that's beautiful, and these things, these concepts that humans find appealing also turn out to be the concepts that govern how the world actually works. And I don't think that's an accident. I think humans were evolved to be able to interact with the world in ways that are advantageous and to learn from it. And so we are naturally evolved or designed to enjoy beauty and to symmetry, and the world has it, and that's why we resonate with it.
Well, it's interesting that the ideas of symmetry emerge at many levels of the hierarchy of the universe. So you're talking about particles, but it also is at the level of chemistry and biology, and the fact that our cognitive, sort of our perception system and whatever our cognition is, also finds it appealing, or somehow our sense of what is beautiful is grounded in this idea of symmetry or the breaking of symmetry. Yeah. Symmetry is at the core of our conception of beauty, whether it's the breaking or the non-breaking of the symmetry. Yes. It makes you wonder why. Like, so I come from Russia, and the question of Dostoevsky, he has said that beauty will save the world. Maybe as a physicist, you can tell me, what do you think he meant by that?
I don't know if it saves the world, but it does turn out to be a tremendous source of insight into the world when we investigate kind of the most fundamental interactions, things that are hard to access because they occur at very short distances between very special kinds of particles whose properties are only revealed at high energies. We don't have much to go on from everyday life, but so we have when we guess and the experiments are difficult to do, so you can't really follow a very wholly empirical procedure to sort of in the Baconian style figure out the laws kind of step by step just by accumulating a lot of data. What we actually do is guess. And the guesses are kind of aesthetic, really. What would be a nice description that's consistent with what we know? and then you try it out and see if it works. And by gosh, it does in many profound cases. So there's that, but there's another source of symmetry, which I didn't talk so much about in A Beautiful Question, but does relate to your comments, and I think very much relates to the source of symmetry that we find in biology and in our heads, in our brain, which is that although it is discussed a bit in A Beautiful Question and also in Fundamentals, is that when you have symmetry is also a very important means of construction. So when you have, for instance, simple viruses that need to construct their coat, their protein coat, the coats often take the form of platonic solids. And the reason is that the viruses are really dumb and they only know how to do one thing. So they make a pentagon, then they make another pentagon, and they make another pentagon, and they all glue together in the same way. And that makes a very symmetrical object, sort of. So the rules of development, when you have simple rules and they work again and again, you get symmetrical patterns. That's kind of, in fact, it's a recipe also for generating fractals, the a kind of broccoli that has all this internal structure. And I wish I had a picture to show, but maybe people remember it from the supermarket, and you say, how did a vegetable get so intelligent to make such a beautiful object with all this fractal structure? And the secret is stupidity. You just do the same thing over and over again. And in our brains also, we start from single cells, and they reproduce, and they're each one does basically roughly the same thing. The program evolves in time, of course. Different modules get turned on and off. Different regions of the genetic code get turned on and off. But basically, a lot of the same things are going on, and they're simple things, and so you produce the same patterns over and over again, and that's a recipe for producing symmetry, because you're getting the same thing in many, many places. And if you look at for instance, the beautiful drawings of Ramon y Cajal, the great neuroanatomist who drew the structure of different organs like the hippocampus. You see it's very regular and very intricate, and it's symmetry in that sense. It's because it's many repeated units that you can take from one place to the other and see that they look more or less the same.